Now that we know where we're likely to find linear equations, let's talk about how we graph them. And the most important thing to think about when we think about graphing a line is the notion of the line's slope. So here we have a line graphed, and we notice, looking at this picture, that as we go from left to right, this line goes downward, and it goes downward fairly steeply. The slope of the line is a number that describes how far up or down the line goes as it goes 1 unit to the right. How do we understand that in terms of these linear models we've been seeing? In terms of these linear models that we've been seeing, the slope represents how much y increases when x increases by 1. All right, so let's look at this line and see what happens when x increases by 1. X increases by 1 means we move 1 unit to the right. I just picked this point to start with at random, by the way. If we start at this point on the line and move 1 unit to the right, in order to get back to the line, we have to move down by, each of these little squares is half a unit, right? It's splitting the unit in half. We have to go down by 3 halves. Look, both of these definitions say how much the line goes up, how much y increases. Here, y decreases by 3 halves every time x increases by 1. So here, our slope, decreasing by 3 halves is the same as increasing by negative 3 halves, right? Going backwards by 3 halves is the same as going forward by negative 3 halves. The slope of this line is negative 3 halves. That's not a very nice number, right? If I'd drawn this at a different scale, it would be very hard to read that negative 3 halves off of this. But remember, in a line, when x changes, y changes at a constant rate. We could instead have said, again, I'm going to start at this point. Here we've gone to the right 2 and down 1, 2, 3. So the amount that we've gone up and down is negative 3. The amount we've gone to the right is 2. These numbers are the same, right? Negative 3 over 2 is the number negative 3 halves. Maybe we could have picked a different point to start at. Maybe for some reason we picked this point down here. Now from this point I could go to the right 1 and down 3 halves again. But now I'm getting to the end of the graph and things are looking funky. Maybe I could go to the left 2 and up by 3. That takes me to the line again. Again, the distance we went up over the distance we went to the right. We didn't go to the right, we went to the left. 2 to the left, that's negative 2 to the right. Any way you slice it, right, the slope of the line is the distance the line has gone up over the distance that it's gone to the right. And the wonderful thing about lines is, no matter how we draw it, no matter how big or how small a triangle we draw, we could, for example, start at this point and draw this little triangle. And no matter whether we go to the right or to the left, this ratio will always be the same, including the sign. Of course, we need to remember that going downward means a negative distance up, and going leftward means a negative distance to the right. I'm going to draw another line and ask you to determine its slope, just looking at the picture. Find the slope of the line that you see here. Pause the video and try this now. Okay, we can pick any point that we like to start with. I am imagining that many of you chose this point, but just for the sake of demonstration, I'm going to choose this point down here. And now, let's see. Well, if I go 1 unit to the right, I go up, not all the way from -2 to -1, but just from -2 to -1.5, right? So the amount that I go up is just half a unit. Now that needn't have been what we picked, right? We could, for example, choose to start with this point and go 2 to the right and up 1. Again, the slope will be the amount that we went up over the amount that we went to the right. In this example, I don't see any reason that you would have chosen to do what I'm about to show you, but it would not be incorrect. We could start at this point out here, and now there isn't space to go to the right, but maybe we could go, we're being weird, right? We're going to go 3 units to the left, and then how far did we have to go down? A half, 1, 1.5, or 3 halves units down. So this slope, right, this is a little bit weird. This is going to be -3 halves. We went down by 3 halves over -3. We went left by 3. Right, now notice that this is a negative divided by a negative. So this is going to still be a positive number. If we simplify this, again, we get +1/2. No matter which one of these we choose, we get the same value for the slope, which is +1/2. We often use the letter M to represent the slope, presumably because slope starts with the letter M or something. Now, the value of M, the value of the slope, which notice is just a number, tells us something about the shape of the line. If M is a number that's bigger than 1, right, that means that when we go 1 to the right, we go up more than 1. So the line will slope upward, and it'll do it steeply. We'll see something that looks kind of like that. If M is a positive number, but smaller than 1, that means that when we go 1 to the right, we go up less than 1. So our line will still slope upward, but it will be shallow. If the slope is exactly 0, that means that when we go 1 to the right, we don't go up or down at all. That gives us a horizontal line. And now negative slopes give us downward sloping lines. If M is a negative number, but still bigger than -1, that means that when we go 1 to the right, we go down, but by less than 1. That's a line that will be shallow downward. And if M is a negative number that is less than -1, that means that when we go 1 to the right, we go down by more than 1. So that'll be a line that is steep downward. Keeping these in mind provides us a really good way to check that we've graphed correctly. It's a good way to look and see if our line looks right.